Forensic chemistry is the application of scientific methods to analyze evidence and uncover the truth behind crimes. Every crime scene holds hidden clues that cannot be seen by the naked eye, but through proper investigation, these clues can reveal what truly happened. In this video, we will explore how forensic science developed over time, the principles that guide it, and how it is used in real investigations. By combining science and law, forensic chemistry plays a crucial role in delivering justice and ensuring that facts remain objective and reliable.
The development of forensic chemistry began with early scientific breakthroughs such as Marsh test in 1836, which allowed investigators to detect arsenic poisoning. Later, in 1910, Edmond Locard established the first crime laboratory in Lyon, France, marking the start of modern forensic science. In the Philippines, forensic practices involved from early chemical methods during the Spanish period to the establishment of advanced laboratories under the Philippine National Police and the National Bureau of Investigation. These developments show how forensic science has grown into a reliable tool for solving crimes.
As forensic science continued to evolve, new techniques such as fingerprints analysis, DNA profiling, and advanced chemical testing furthers its role in investigation. This innovation allowed experts to move from simple observation to highly accurate identification. In the Philippines, continuous improvement in forensic facilities and training have enhanced the capability of investigators to respond to modern crimes. This progression reflects how science adapts to meet the growing demands of justice.
Golden Rule. Types of evidence. One of the most important principles in forensic science is Locard's exchange principle, which states that every contact leaves a trace. This means that whenever a person interacts with an environment, they leave behind evidence such as fingerprints, fibers, or chemical residues. Physical evidence can be categorized into biological, trace, impression, and chemical types. Each category provides valuable information that helps investigators reconstruct events. Through careful analysis, forensic chemistry ensures that evidence remains objective and scientifically accurate.
Forensic chemist. Each type of evidence requires specific methods of collection and analysis to avoid contamination or loss of important data. For example, biological sample must be preserved carefully to protect DNA, while trace evidence must be collected using precise tools and techniques. By applying proper scientific procedures, forensic chemists can provide reliable results that helps reconstruct the sequence of events. This careful approach ensures that conclusions are based on facts rather than assumptions.
Forensic evidence must meet legal standard before it can be used in court. The Frye standard requires that a scientific method be generally accepted by experts in the field, while the Daubert standard evaluates its reliability based on testing, error rates, and scientific validity. These standards ensure that forensic evidence is credible and trustworthy. In legal proceedings, scientific findings are used to support or challenge testimonies, making forensic chemistry an essential part of the justice system.
In addition to these standards, proper documentation and expert testimony are essential in presenting forensic evidence in court. Experts must clearly explain their findings so that judges and juries can understand the scientific basis behind them. Any error in handling or interpreting evidence can affect the outcomes of a case. Therefore, maintaining accuracy, transparency, and professionalism is critical in ensuring that justice is fairly served.
Evidence at a crime scene comes in many forms, and each type provides unique information that can help investigators solve a case. Biological evidence such as blood, saliva, or hair can reveal the identity of the victim or suspect through a DNA analysis. Trace evidence like fibers, glass fragments, or paint can link a person to a location or object. Impressions including footprints, tire tracks, or tool marks help reconstruct movements and actions at the scene. Chemicals and toxicological evidence such as drugs, poisons, or accelerants in fire cases can explain causes and timelines. By carefully collecting and categorizing and analyzing these clues, forensic chemists transform ordinary objects into powerful tools for uncovering the truth.
The chain of custody is the process of properly handling evidence to maintain its integrity. First, evidence is carefully marked and tagged at the scene. Biological samples, such as blood, are placed in a paper bag to prevent contamination, while chemical or arson-related materials are sealed in airtight containers. Each piece of evidence is labeled, sealed, and documented, including the time, date, and the person handling it. This process ensures that the evidence remains untampered and can be accepted as valid in a court. Failure to follow the chain of custody can lead to evidence being questioned or even dismissed in court. That is why every individual who handles the evidence must follow strict procedures and record each transfer accurately. Proper handling not only protects the evidence but also strengthens the credibility of the investigation. By maintaining a clear and documented process, investigator ensures that justice is supported by trustworthy and untampered evidence.
In every investigation, the truth does not rely on assumptions, but on evidence that speak through signs. Forensic chemistry allows us to uncover what cannot be seen, transforming small and often overlooked traces into powerful facts. From its historical beginnings to its modern applications, it has become an essential tool in solving crimes and delivering justice. Guided by principles like Locard's exchange principle and strengthened by strict legal standards, forensic science ensures that every piece of evidence is carefully analyzed and properly handled. Through the chain of custody, we protect the integrity of that evidence, making it reliable in the eyes of the law. As we have seen, every clue, no matter how small, has the potential to reveal the truth. In the end, forensic chemistry reminds us that science is not just about discovery, but about justice, where facts remain objective and the truth can never be hidden.